Okay? What we're going to do today is called like composition of transformations or combination, right, of transformations. The idea is we're going to take translations, rotations, and reflections and put them together and do them in succession, so one after the other, okay? So for example here, in example 1, we're going to look at this example, and then we'll try one on our own over here. Okay, so let me zoom in some so you guys can see that better. Okay, so sometimes we can use a single transformation to describe the result of applying a sequence of 2 transformations. We'll actually look at that tomorrow. Sometimes 2 transformations can really be described using just one, okay? But we're not going to worry about that right now. Now we're going to apply sequences of rigid transformations that cannot be described by a single transformation. So first of all, can anyone remind us, raise your hand please if you can, what is a rigid transformation? Jason?
Wait. Doesn't it like turn or something?
So
So
let me ask you this. In a rigid transformation, Jason, does the size of our figure change?
No.
No. Does the shape of the figure change?
No.
No. So rigid means it maintains its size and shape. It stays the same. Okay. In a non-rigid transformation, like a dilation, right? And we'll look at more of those in another unit. They don't change. They do change shape or size sometimes. Okay. Anyway, so. Okay, let's take a look at this one here. So the directions say to draw the image of triangle ABC after the given combination of transformations. So letter A here, okay, in this example, we've got our triangle ABC, we've got a line L here, and then this is a vector.
So it's going upward.
So hang on. So it says to first reflect over line L, then do a translation along vector V. So the first thing we have to do here is reflect this over line L, and then translate along vector V.
That's not that hard.
Okay, now, it's not that hard, but here's the thing. If you look at this, thank you, okay? Our line of reflection here is not a horizontal or vertical line, so it can be kind of hard to reflect here, like by eyeballing it, right? I mean, for example, A, that's going to be an easy point to reflect. Where's A prime going to be? It's the same spot, right? If A is right here, then A prime is also going to be right there, right? But to reflect over B and C, that's going to be a little bit trickier because they're not exact, like we can't exactly count from C to our line of reflection. So if we can't really count them, what's another tool that we have at our disposal to help us reflect? Yes, my wax paper, the patty paper, okay? So I'm going to come around and pass out a piece to everybody there, okay? So there you go. And so go ahead, and if you want, just make sure you can do it. Practice reflecting. I know it's not the same. Practice reflecting. You have some already. Can you pass them down?
Oh, I'm gonna audition like well, it's a very old movie, and they turned it into a play, I might get a really good role. I'm aiming for
okay.
long-time girlfriend.
So go ahead and reflect. That triangle, just make sure that you can, okay? So if you forgot how to reflect, let me refresh your memory. So I'm going to use my patty paper here, my wax paper, which is it is now, okay? And I'm going to put it kind of in the upper left-hand corner. Why am I doing that? Well, because I'm just trying to save some space on my patty paper here. So when you do this, you want to put points at the ends of your line of reflection. This will help you make sure that you get your line of reflection lined up correctly. Okay? And then you also want to recopy the vertices of the triangle. Right? Just like so. See that? If you want to actually draw inline reflection, that's not a bad idea. I'm going to freehand it. You probably should use a straight edge, but... Yeah, the other patty paper was better. I apologize. It should still work, though. But this is what I was able to get at the grocery store because they don't have patty paper at the grocery store. Okay? And then to reflect this, what do? You flip the paper over, line up your line of reflection,
We're gonna get the prime.
You can just poke holes in it. That's
and then trace. And you can poke holes if you'd like to, that's fine, yep.
poke holes.
If that's what you're comfortable doing.
That way.
And see, I can see just the faint traces there of those original points, or the reflected points, and so that'll become B. And see, I should name this point not just B, but B what?
Prime.
B prime, very good.
And then you
And then C prime, right?
one of those is prime.
And so then we connect the dots and draw our reflected kind of shape in there. Okay?
I mean, it's kind of really simple, to be honest. Mr. Wood, I
Question.
can't wait till we get to B prime.
Right. Well, I don't know if we might get to some of those. We'll see.
No, I don't enjoy it.
So we are, this is something I can tell you that will show up potentially on like a CREST benchmark too, okay? They've used them in the past, I know. So we definitely want to make sure we know how to do these, okay? I know they can be a bit of a hassle because there's a lot of work involved with them. Okay.
Can I play?
It's kind of hard. You got to be patient with it. That's all, okay?
What kind of paper is it?
It's wax paper. I made my own because I ran out of the good stuff. Okay. I think I have another idea though, Ramel. I'm going to try and get some parchment paper. I think that'll work better. I get that from the grocery store too. Yeah, I agree. You're right. It is not the same.
Patty paper from the grocery store.
Well, no. You can't get patty paper from the grocery store, but you can get papers that are similar to it. Okay? Shh. So, Julio, are we done here? Is that it? Shh. So, no, what do we still have to do here with this shape, Julio? Translate, that's right. Now, am I going to translate ABC as well?
No.
Yeah, we're not going to translate ABC as well. We're only going to translate A prime, B prime, C prime. So once we've kind of done this reflection here, we now kind of ignore this shape. It's no longer what we're going to use. We're going to translate this, only this triangle. Okay? So yeah, we're going to go up 1 and then right 4. I'm going to go ahead and up 1 and then right 1, 2, 3, 4 like that, and that is going to be C prime prime, right? Because that's been translated
Well, wait a minute.
and reflected. All right.
Wait a minute.
All right, hang on. Let me finish here, EK, and then you can ask a question. All right, and we're going to go up 1 and right 4 again from the B prime. So up 1, right 1, 2, 3, 4. B prime prime. And then from A prime, up 1 and right 1, 2, 3, 4. And then there's A prime prime.
Mr. Wood.
All right, hang on. Let me finish drawing here.
I'll wait.
Okay? And so there it is, translated. Okay, now, yes, EK, have a question.
Okay, so when you have a vector line
Yeah.
and you get 1, 5, you're supposed to flip it because when you make a point, 5 goes first because you're going 5 to the right and then you go up 1. Oh.
It is 4, yeah.
Same concept.
So say it one more time, though. I'm
Okay,
sorry.
So you know how you taught us, and it's kind of common sense, that when you have a vector line,
Yeah.
and you get up 1,
Uh-huh.
you go right 4,
Yep.
and then you rewrite the vector so it's 4, 1. Because when you
Right,
make
the
a
vector
point-
would be written 4 and 1 in its component form, yes?
Right, so when you make a point, like you go right 4, and then up 1.
Yep, that works. C prime. 1, 2, 3, 4 right, and up 1.
I don't know what I did.
Okay? So yes, it doesn't matter whether you choose to go up first and then right, or right first then up, that's okay, okay? But you need to make sure you're doing the right counting there, that's all, okay? Wait, hold on a second, sorry. Haley?
When it says like reflection over the line L, and then you do that, and then it says, and then translate long.
Yes.
But like, it kind of sounds like it wants you to do it to the prime figure already, like the one that you reflected.
That then translate, right?
Yeah.
And that's what we did, right? I took this shape and then translated it. This is the reflected image, and I translated it.
Oh, okay. I don't know what I was doing.
Okay, yeah, that's what we did. That is what we did. Yep, we reflected and then translated it. Okay, so now that we've done that, okay, so Matt, this image here, the final image that we have, did its size, shh, listen please, did its size change from our original?
No.
No. Did its shape change?
No.
It didn't.
Yes.
Did it or didn't it? So how did it change? Okay, so right, it's like the shape we might say is still the same, but the orientation maybe we would say is different, right? Because it's still a triangle. It's just it's turned a little bit, right? Well, really, it reflected and then translated, like you said. Okay, so is this from our original to my red figure here? Is this a rigid transformation, Matt? Would you say it's a rigid transformation? Yeah. Size did not change. Shape did not change. Orientation changed. The order maybe of the points, but it still kind of changed the size and shape stayed the same. Okay. Yes, Jaden. Sorry.
Can you write 1-4?
So for this, okay, good question. Can we write 1-4 here? Is that the same vector? Anybody? Is 1-4 the same? Yeah. So no. Okay. Did you hear that, Jaden? This means go 1 to the right and then up 4. This means go 4 to the right, up 1, which is different. Okay. But Jaden, it's just like a coordinate, a point.
Yeah, but those go like 1-4.
Ramel, what's going on over there? What's that? Okay, so let's pick it up quietly. We don't need to say whoa. We don't need to make noises, laugh. Okay, let's take care of it, please. All right? Being a little silly over there. It's like I maybe made a bad choice. Might have you and Gabe switch seats so I can see you. Gabe's blocking you, and that's not good. All right, so anyway, so Jaden, okay, it's just like a point, right? The first number is like your left or right, your x coordinate. The second number is your y coordinate. So the first number always tells you which way you go, left or right. The second one always tells you which way you go, up or down. That's all. Okay? It's just like a coordinate. Your plot point. Not in this case you didn't have to, but you should be able to write what the vector, is. Like you should be able to write from this to that. Right like that. Okay? Okay, like that. Okay? Alright. Let's try another one. Here we go. Okay. So letter B says to rotate 180 degrees around point P, then translate along vector V, then reflect across line L. So we have 1, 2, 3 transformations to do here. Okay? So you're going to need your protractors, and if you don't have one,
Can I use, oh, my bad, sorry.
so
Wow, now you pick it up.
What? I didn't drop anything.
Oh, I thought you like knocked something on the floor.
anyone else need a protractor here?
Sorry.
You got any protractors?
Oh.
Where's the Patty wax paper?
It's where should I put that?
See, no, I already got
Oh,
mine.
you have one? No, it should be all done.
I never got one because Mr. Harris took it off.
Where did I put it? All right, I'll find you some, Jason. Just have it here right now, I think.
I think I have it next one. Yeah, I have it. That is fair. I had yours from
Mr.
last.
Wade,
Yep. What's that? Oh, you need a protractor? Okay, I'm coming around. I don't know where my...
where?
You got any protractors right now?
I have,
Protractor? Okay, you need protractors here? Hey, Billy, you need a protractor? Yes. Okay. You need one, Jordan? Really? There you go. No? Oh, here it is, Jason. Hi.
I didn't even get a protractor.
Well, that's not him.
there you go, that's all I got right here.
Mr. Witt,
Yes.
has anyone ever told you that your hair is very swoopy?
Yes.
Really? Sorry, I'm not sure.
Question? We're going to go over that right now, actually. We're going to do that. So yes, sorry guys, we're going to go over how to rotate here real quick because some of us I forgot. And it is kind of tricky to rotate, so...
Oh,
Alright.
it is a
So let's first of all do our 180-degree rotation around point P. So there's point P. Okay, now we've got all of our tools and things here. And remember, what do? We have our shape here, the triangle. What do we do to start our rotation here? What's our first thing we're going to do?
You connect.
Yeah, we need to connect point P to either C, A, or B. It doesn't matter which one. I'm going to do it to C because it's the closest. Okay, so just like that, nice little horizontal line right there. You can use your straight edge, but it's like so small, it's just, just draw it, right?
It doesn't give you direction, you go counterclockwise, right?
So, exactly right. Since we are rotating 180 degrees, well, but actually for a 180-degree rotation, does the direction matter?
I guess.
No, the answer is no, right? Because 180 degrees is the same clockwise as counterclockwise. So I'm going to go ahead and just do it clockwise because that's the way my paper is kind of oriented here. Okay? So now I'm setting my protractor down on my paper. Okay? So there it is. I've got my point P centered in my protractor. My protractor has a little dot here. Some of you guys need to line up your point P on the bottom of your protractors, but mine has a little circle there, so I have to line up in the circle, in the target. Okay? And then, if you see here, one side of my angle, it's teeny tiny from P to C there, but that one side of my angle, okay, that's the start of my angle. And so which set of numbers should I use here? The outside numbers or the inside numbers? Outside, because they start at 0, right? And I need to go 180, so all the way over to here. Okay, and I can barely mark it on my paper right there. Okay, I can barely mark it, you can see. Okay. And so we want to go 180 degrees. I'm going to kind of like draw that out here. Okay, like so. Now we take our patty paper. Okay, take your patty paper, and we're going to trace point P. Okay, point C, A, and B. Okay, and then don't forget to draw the little PC segment, too. Don't forget to draw the little PC segment. So it should look something like this. Okay? It does, just give it a little time. I mean, you just have to give it a little... It will work.
So what do we do? What do we do once we...
So again, we traced point P, we connected P and C, and we traced B and A as well. So you have those points right there. You see it? And if you want to label them, you can. Sometimes you have to like write over it a couple times for it to write still, but it'll work. Okay, so you can kind of see them. Okay? And so then we rotate 180 degrees about point P to the other side of our angle, and there it is. Okay, so again, I'll go back over again. So for you, those who had difficulty, there we had it traced, right? We're going to rotate around point C. If you want to try and like put your pencil point down to keep it where it's supposed to be, that'll help too. And you can see they line right back up. Okay? Now, I think with this wax paper, I was able to do it. Nah, it doesn't quite work. So you need to draw on the backs of the points too.
I just poke holes in it.
And then, yeah, Jason just pokes holes in it, and that works. Okay, I'm going to draw on the backs of my points, though, and then put them back where they were, like that. And now it should recopy. All right, hang on. So there's C. This one will be A, and that'll be B, primes. Shh, Ramel, I still hear you talking, buddy. Come on. What's going on here? Are you sorry? Because I keep hearing you do it. Okay. And then I'm going to reconnect those dots like so. Okay, so there it is, rotated 180 degrees around point P. All right. Let's see here. All right, so then, Garrett, what's the next thing that we're supposed to do here?
I'm sorry, I'm still trying to catch those.
Okay, that's fine. What's the next thing we're supposed to do after the 180-degree rotation? What do the directions say?
Translate along vector V.
All right. So did you get it rotated yet, Garrett?
Yeah.
Just about? Okay.
How do you rotate it?
So again, once you have everything copied on your wax paper, you just keep point P on the point of rotation. You're rotating it around point P. So you keep point P on point P, and then there it is, rotated, 180 degrees. So it lines up to the other side of your angle there, 180. Okay? So there it is. All right, now, next thing. So Garrett, we already rotated. That was the first thing. Now we're supposed to translate using vector V. And Garrett, what does vector V tell us to do? Which directions are we supposed to go? Up how much? Up 1, and right how much? 5, that's right. So then this A prime, B prime, C prime, we're going to go up 1, right 5. So again, we do not translate A, B, and C. We do not translate A, B, C. We only translate the A prime, B prime, C prime, because that's the last thing that we did. So for each one, you're going to go up 1 and then right 5. And we're going to call those prime primes now. Up 1 and right 1.
Right.
Okay. And then up 1 and right.
Okay, what page do I start with?
Like to tear out, you mean?
Yeah.
Oh, you want to head? Well, we're going to go up to 119, the top of 119.
I mean, I'm sure I could. I mean, my legs are short enough.
Up the top 2 of 119. We might not get to both. If you just want to do like the number 11, that's up to number 11 now. That should be fun.
I need to smell like
Shh. Okay, so up 1, right 5. There's that one. Okay, questions on this? We're all okay with this? Translate everything okay? All right, and we're not quite done yet. We still have one more thing to do. So, Ikeba, what's the last thing we have to do here?
Well, you have to get your patty paper out,
Uh-huh.
and you have to make points on the end of your line and make your line L, because you're reflecting line L.
For this one second though, for this one, do we need to actually use patty paper here? Yeah,
I
no.
can't eyeball.
And that's fine, Ikeba. Let me show the quick way to do it, and then we'll do your way. But remember here, for example, C prime prime is exactly 1 square above the line of reflection. So that means C prime 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 will go where? 1 square under. That's right. Okay. A prime prime is 3 squares above. So A prime prime prime, its image, will go down 1, 2, 3 right there. And then B prime prime is 4 above. So then you just go 4 below, and that'll get you B prime prime. So when you have a nice horizontal or vertical line of reflection, it's much easier. But Ikeba, you're exactly right. We can absolutely just trace it and reflect it using our patty paper.
Can't eyeball.
Okay. And sometimes people have difficulty with that, and that's okay. That's okay.
You know, I remember that one time when you were like, B prime prime prime. I think you should say prime prime prime.
Prime prime.
Yeah.
Right. I want to make sure people can hear, though, to understand what I'm saying. So anyway, we take it, right, and we reflect. And we just flip it over, and then draw on the backs of our points. Make sure you line back up those little points for the ends.
Well, yeah, you're the only one.
Okay. And there it is. 1, 2, and 3. And I'll do this one in red because our final image is normally red like that. Okay. Okay, and so there is our final answer right down there. Okay, there is our final answer right there. Okay, so any questions on that? Guys, this is not easy, right? Jason, okay, Dominic, guys, this is not easy. You can make one little mistake here, and then that's going to carry your mistake through to there and there. So please take your time with these, okay? Try and do them as best you can. All right. If you make a mistake here, I'm not going to like count against you here and here, right? So if you make a mistake here, but you still translate the mistaken image correctly, and then you reflect the mistaken image correctly, then I'll still give you points for those 2 things. But you know, we want to be very precise with each one of these, and you know, well, partial credit. I can't say exactly how much, but partial credit, yes, partial credit. Okay. Okay. So let's have you guys try here number 7.
That joint's kind of hard. No,
What do you want me to call it?
Let's try number 7, please.
Number 7.
on your own. So you're going to do a 90-degree rotation after doing reflection. So reflection first, then a 90-degree rotation around point P.
This wax paper like ruins my pencil point.
Yes, I'll try and get some parchment paper for us. I think that'll work better
Parchment paper?
Yeah.
Oh, can I bring my own parchment paper?
if you want to, sure.
I'm bringing my own.
Okay, so go ahead and try number 7, please. I'll do it real quick and I'll come around and help. Okay. So hopefully the reflection should be pretty quick because it's just counting. Okay.
So, Mr. Webb,
Question.
shut up, so you have A prime, and then you connect that to P, right?
You can do A prime, you can do C prime, you can do B prime, any of them.
Okay.
Yep.
I've worked so hard.
Ooh.
Did you go see Little Shop of Art at SCC, Mr. Wood, over the weekend?
I did not, Ikeva.
Well, that's a shame because it was really good.
I've never seen it. I would like to at some point, though.
It was awesome.
Okay.
I did really
Okay. Phew. So remember, you want to reflect this around point P, or sorry, rotate this around point P 9 degrees. So you did around point B, it looks like. Okay, so yeah. So yeah, make sure you're rotating around point P. Once you reflect it, you're going to reflect first. So you want to reflect it first and then rotate around point P. Okay, so if you want to just, you know, scratch that out, and then because it actually won't get in your way. So reflect it across, and again, it says reflect first, then rotate. Question.
well, that's not right.
Says reflect across L, then 90-degree rotation around point P. You're doing rotation. So reflect across L. I think we can just count it too, remember? When it's reflected, you're gonna you can use that still if you want. Trace your line of reflection. If you like, you can just move it. And then make sure what I do is also.
How much work to do? The cello.
Okay, now how do you reflect that?
Oh, there it is.
I mean, flip it and like, back. Line it back
What
up.
is this? Oh.
Okay?
Amazing.
Alright, let me get that out of your mind. Your reflection looks good. I think you rotate. Where's your point of rotation? Oh, right here. Oh, don't reflect point P. Point P stays where it is. You still reflect around that point P. So yeah. So sorry. Good thing I saw real quick. Okay. Only triangle ABC is reflected over line L. Point P stays where it is. You still rotate around that point P. Okay. So ABC reflects, and then you rotate it around where that point P is. You don't reflect point P. Okay. Don't. Yeah.
Okay, so like I drew my little points and then I put my P already, and then it doesn't go on a point.
It does roughly. Let me see. That looks good. Yeah, that looks
Yeah, but
good.
that's not on a point.
It's basically on a point. I mean, just scoot it over just a little bit and it's there. That's where it should be. That is where it should be. Okay, that is right. Okay. Okay, some of these are still looking a little bit tricky here. I think some people have some difficulty with the rotation aspect of it. Okay. So there it is. Okay, this is what it should look like. So again, reflecting ABC, reflecting it, and then rotating it around point P. Okay, that's point P. So again, I drew a line from P to C prime there.
Wait, why is it counterclockwise?
Because what direction were we told? No direction. But when we're not told a direction, that means we assume counterclockwise. Yeah, we always assume counterclockwise. Counterclockwise. Oh. From the Empire, huh?
Yeah.
Okay. Okay, so there's where it should end up. Okay. Questions on that? We're going to do one more here. We have time for one more. Okay, time for one more.
What is, I've never seen a vector used.
Just as a different name for the vector because you're going to be translating it twice.
So the, like, EGF is translated along V, and then
Yep.
that shape gets rotated
180 degrees.
around P.
Yep.
And then you translate it along U.
Yep, exactly. Yep. We're not going to do that one though, but just because we don't have the time for it. I want to move on to a different one that actually changes the size and the shape. Okay. So here we're going to flip over to this next one here. Okay. Another, excuse me. Another way we should be able to do these transformations is to be given them in kind of this like coordinate notation here. Okay, so you can see, for example, we're going to take our original coordinates x, y, and then it asks us to do a 3x, comma y, and then it asks us to do 1/2 x, comma negative 1/2 y. Okay, now they don't leave us very much space here, but I think we can fit it right down in here. Okay. I recommend, when you do this, to actually like write it out. So what do I mean by that? Well, let me show you. Again, we're on page 118 here, example B. So I'm going to write out like x, y, and then the arrow 3x, comma y, and then the arrow 1/2 x, comma negative 1/2 y. Okay? So here's the point x, y. And I'm going to write down the original coordinates here, right? Because that's what goes underneath x, y. It's my original points. So A, it has coordinates 0, negative 2. Okay, and I'll kind of scoot in some more here. B, it has coordinates negative 2, negative 4. And then C has coordinates negative 4, negative 4. Okay. We can do this work for these types of transformations because they're on the coordinate plane. The problems we did before this, they were on grids, but there were no coordinates, so we couldn't like copy down their coordinates. Okay. But here, since we're on the coordinate plane, since we have coordinates and things, we can actually write down their locations and then do the transformations this way. Okay.
And you put 1/2 of parentheses when you use your calculator, right?
Alright. Because yeah, with fractions. Yep. Okay, so now let's do this first transformation that they're asking us to do. Okay, so it looks like it's just asking us to take the x-coordinate and multiply by 3. So A prime, well, what's the x-coordinate of A? 0. So 3 times 0 is still going to be 0, and the y-coordinate stays the same because it's just the y. Okay?
Wait, what?
Y-coordinate is just y.
Oh, we're transferring it 2 times.
Yeah.
Wait, would it be negative? Would it be negative 2 or 0?
Oh, sorry, thank you, Matt. It's negative 2. Thank you. The negatives, yeah, it's still the same number. Thanks for pointing that out. Yep. Okay. For B prime, okay, our x-coordinate for our B is negative 2, so B prime's x-coordinate will be what? 3 times negative 2, which is negative 6, and then the y-coordinate stays the same, so it's still negative 4. And then C prime will be, let's see here, 3 times negative 4 is negative 12, and then Y is still going to be negative 4. Okay? And so now that we have these 3 points, we did the math for them, we can actually plot them. Okay? So 0, negative 2, so A prime still stays where A is. Okay? B prime is negative 6, negative 4, so there's B prime. I'm sorry, you guys can't see that. Let me zoom out just a tad here. Okay, there's B prime, and then C prime is negative 12 all the way out here, negative 4. And so we get this new shape there. Was this first transformation, is it a rigid transformation? Nope. Yeah, very clearly not. How would we maybe describe this transformation? What can we say happened? What happened to our original triangle here? Sorry? Is it exact? But did it go 3 times in both directions? It only stretched
3 times longer.
Yeah, 3 times longer. It stretched horizontally 3 times. So it's 3 times stretched out horizontally. Okay? But vertically it stayed the same. We're going to do one more then. And let's finish off for A prime prime, B prime prime, C prime prime. Okay? And now we're going to do some halves. So half of 0 is still 0. Negative 1/2 times negative 2 is a positive 1. Okay? And this is all stuff you can do in your calculator too to help you out. But negative 6 times 1/2 is negative 3. Negative 4 times negative 1/2 is negative times a negative, so it's positive 2. And let's see here, 1/2 of negative 12 is negative 6. Negative 1/2 times negative 4 is positive 2. So there are our 3 new points, and we'll plot those down. Okay, so A prime prime is 0, 1. B prime prime is negative 3, and we'll talk about why that is in a second here, negative 3, 2. And then C prime prime is negative 6, 2. So would anyone like to try and identify here, why did our triangle get smaller here? What happened? Right, what did we do? We multiplied our coordinates by 1/2, so it should have shrunk the triangle down some. We still have that stretch in there, but now everything is shrunk down. Okay? So it's kind of like a dilation there for that second one, because well, it's not exactly a dilation because one was negative, one positive. Okay? Now, for your assignment, okay, so let's flip over here. For your assignment, okay, you'll see the homework here is listed. Okay? I would like you to try, I'm not going to give you a bunch of these because I'm going to take some time. I would like you to try page 122 to 123. I would like you to try numbers 1, 2, and 5. So page 122 to 123, numbers 1, 2, and 5. Okay, so I'll write them on the board here too. You want to circle those? Page 122 to 123, numbers 1, 2, and 5. Okay? If you need to take your protractor home with you, okay, feel free to do that because you are going to be doing a rotation. Okay?